Introduci te, giusto?
Welcome back. Gianluca is about to talk about test-driven development and why it's not just about testing.
Yeah.
Gianluca, good luck.
Okay, thank you. First of all, thank you very much to be here today, and I'm very happy to join this community. So yeah, thank you. Also after the lunch, so I hope that you have eat something good, something healthy, and yeah. So we could start about talking test-driven development. So. First of all, to talk, so please yeah, thank you very much. Okay, so yeah, TDD is not about testing. Okay, so why this strange title for this talk? Because clearly TDD, test-driven development. So why is not about testing? Okay, we will see during this session. First of all, some words about me. My name is Gianluca, so you can call me also with SGPad. So this is my nickname. You can find me at SGPad on internet, and especially if you look at my avatar, that is a fractal broccoli. So yeah, and I am the CTO and founder of Codesys 51. That is a small company, software agency. So we are growing, we are hiring. So please contact me if you want to also to make a chat. So I have started to work in this field a lot of time ago. So in the last century or in the last millennium. And so I have worked in a lot of different languages. A lot of time spent on C++, C#, JavaScript, and so on. So in the last 6 years, I have fallen in love. And so my focus was on functional programming, especially some concurrency language like Elixir and Erlang, but C++ is still in my heart. And so I'm here to talk about TDD and how to do TDD. So this is not a talk focused on how the nitty-gritty of C++ work, but clearly all the example is done in C++, but we will talk also on some concepts that are general and can be applied more or less on every language. So stop talking and start. So the schedule of this talk is what is TDD, why TDD? TDD is not unit testing, is not only unit testing. TDD in OP, so there are some difference if you want to apply TDD in an object-oriented language or in a functional language, but yeah, the concepts are the same, and some example. Okay, first of all, some history. So I am an old guy, and as I told you, I started to develop a lot of time ago. So I'm always happy to talk about some history, especially some things like TDD that start a lot of time ago. So from Wikipedia, the CC project, that is a very famous project, started in 1993, was developed in Smalltalk, and so this is a project quite famous in the Agile environment because it was the first project where Agile and all the related technique, like TDD, for example, was applied. So in the 1996, Ken Beck was hired to the company, and until then, so from 1993 to 1996, so 3 years of development. This is the project about paycheck, and no paycheck was printed. So good result. And so yeah, in the next year, so Ken Beck start to develop with clearly all the team to develop this part, and in 1997 the development started to adopt a way of work that is called extreme programming, and TDD is one part of this of this methodology. And so, yeah, 1 year delivery target. So, yeah, if you want, take the story because it is very interesting. And so, why TDD? So, in that year, if you remember, the main topic of development was UML. So if you see, we are more or less in the same year, and in 1997 UML was adopted as a standard. In 2005 became an ISO, and so yeah. During this year, so if you are not old enough, if you want to start development, you have to apply a very old, a very heavy methodology. Like, for example, you have to define all your class or your method using some tools like UML. And so clearly it was quite difficult if you want to get some result quickly. And so as a response to this way of work, Canback and all the group related to the extreme programming started to adopt a very different approach. It is called like the extreme programming for a lot of other methodology, but one of the talk today is TDD. And so this is a response of Canback on core about what are the roots, and so where TDD comes from. And so the original description of TDD was in an ancient book about programming. And so they talk about rediscover the TDD. So the idea of TDD is, okay, if I formalize the input of one function or one part of my program, and then develop the input and the output, and then I develop some software that connect the input and the output. So the very simple idea. And so when I can't talk also with older programmer than him, these programmers say, of course, how else could you program? And so often Canback talk about rediscover TDD because more or less he has formalized this concept and is not invented from zero. So, okay, from Wikipedia, what is TDD? Okay, TDD is a test-driven development. Is a software development process that relies on the repetition of a very short development cycle. Requirements are turned into very specific test cases, and the software is improved to pass the new test only. Okay, in this sentence, as you can see, TDD is called as a software development process. So it is not a testing process, but it is a development, is a process that help us to develop our code. And so clearly the TDD should help us to develop new code and also clearly better code, we hope. And okay, this is opposed to software development that allows software blah blah blah. And so again the concept of rediscover and so on. So what is TDD? Okay, if you want to make a picture about TDD, probably this is what you get. This is also a quite famous picture, and as you can see, I am the new Picasso of the next century. And so you can write a filing test, and this is the first step. Make the test pass and refactor. Okay. So if you want to describe better all the steps that describe the TDD, we can say, okay, first of all, add a test. Run all tests and see if the new test failed and or is read, is saved as read. This is a very important process and a very important step, because during this step, you say that your expectation, your hypothesis is correct. Because sometimes, if you have some experience with TDD, you write a test, you run the test, and you see the test is green. And this is a very interesting point, because sometimes you think something about your system, and right in the test you discover that this functionality, the functionality that you assume this is not correct, this is not yet implemented, is already in your test, or the test that you have written is not correct, because, for example, you are not checking the correct data, you are not acting in the correct way. So this step of running the test and see that the test is read is very important, because this is the verification of your hypothesis. Okay, then write the code only to make the test pass. This is another point that is very interesting, because the concept of TDD is always a ping pong between test and code. And so one of the first mistakes that the new developer of TDD, the new applier of TDD often made, is to write one test, made all the implementation, run, it's green, and I finish it. This is not the correct way to apply TDD, but TDD is always a ping pong between add a test, add a small code, add test, until you get the correct result. So this is a very baby step. And also, if you have a very experienced developer, you will continue to apply this code, and sometimes you can cut the corner, so you can make a shortcut, but it is not your normal way of develop if you are like me, a TDD addicted. So then you, after the writing, you write the test, you run the test, and you see the test green, and then you are in a position to think and to look your code and try to refactor and say, okay, this part of the code is not very expressive. How I can refactor, how can rename, how can extract some part. This code is very big, and so I want to extract another code. And it is very important to apply this refactor only when all your tests are green, because in this way you are sure that your code is in a correct state, and so you know that until now all the code is correct. And so if after the refactor some tests broke, and you can say, okay, I can roll back and make another type of refactor, and then clearly repeat, and that's all. So if you are in a loop, more or less like an hammer that run inside the circle, you will develop your system. Okay. So first of all, why TDD? Okay. Because clearly you get less bug, because I like it, but the more important, because I feel more comfortable, because clearly when you write your code in this way, you are sure that your code do what you expect, unless what you have understood from the specification. So often say, some questions that sometimes arise from the new developer is, but if I don't understand the specification, TDD can help me. No, I'm sorry. So, but you could be sure that what you have understood is what you have running until now. If you have understood something wrong, I'm sorry for you. But if you understand that some specification is not correct, or you didn't understood the correct flow, you change your test to explain the new and to meet the new requirements, and then you see which test became red, and so change your code accordingly. But the real reason to apply TDD is because it helps us to create a good design. Remember this word, help, and not give. TDD, why it can help us to create a good design? Because TDD first of all change the point of view. Because when you start to write the test, you don't think about how the code is implemented, but how the code should be used by some part of some other part of your system. And so say, what are the functionality that I have to implement? And so you are writing, when you write the test, you are writing a running specification, okay? So you write inside your test some specification that then you have to meet with your implementation code. Force the developer to think about the behavior, we have already discussed it, because you have to understand which behavior I have to implement. And if you have some difficulty, some pain to write your code, this test show us what are the problem of inside our production code. We will see later during the talk. One important part is if the test talk, we should or we have to listen, and often we ignore. I have seen, I made some consultancy in a lot of different company, and I see the test screaming and screaming in pain because they are saying, oh, this production code is not good. And the people say, oh, where is the tool that can give me better TDD? And we will see this is not a tool problem. But yeah. Okay, so listen the test. So this is an example of a test that I've seen a lot of time in my career. So this is a test that are saying something to us, okay? So there are clearly a lot of issue on this test. But yeah, this test is run and probably it is green because this is the implementation of that part of the code, okay? So nothing strange until now, but yeah. So it is not a tool problem, but it is a design problem. Why? So what is screaming the test? So what are the problems inside this test, okay? When I see some tests like this, I see some big problems and some small problems, but there is a lot of problems. So first of all, the names doesn't mean anything. So if you start to think as test as a specification of your code, clearly a test that say mail composer test 1 doesn't mean anything. So if this test fail inside your CI, what do you understand? Nothing. And also when you write this test and you say, okay, this test is failing, what does it mean? Nothing. We are changing a global value. So looking this code, you say, okay, we are instantiating two data, Gino and Pino, and a user repository. We create two user, and then where is user that repository? And where is the test here? Okay, so we are changing a global value. Again, we are changing another global value, a singleton, and so probably this test is not isolated by the other test. Probably if this test crash for some different reason, probably other tests will be affected by this crash. And so, yeah, this is a mess. Okay. How we can do something better? Okay, first of all, change the name. Okay, mail composer test, send email only to the user that accept email. If you look at this test, what is the behavior that we are testing? We don't know. In this case, at least, we understand what is the intention of the developer. So send email only to the user that accept email. Okay, good. So we instantiate two user. We create a repository, and at least we pass the repository as parameter, and so we understand that there is a relation between the composer and the repository. And again, we are passing the singleton as parameter, so this is not the final fixing on the singleton, but at least in this new implementation, we are not using the singleton, but when we instantiate the object, we are passing it. Okay, so now the status is better than before, but yeah, can we do better? This is a very good question. Okay, so first of all, is it clear until now? Do we have any question? No? Can I continue? Very good. So, or you are sleeping, or everything is clear. So I suppose sleeping. Okay. So can we do better? Yeah. Okay. So TDD doesn't mean only unit testing. Okay. So if you think about the definition that we have read inside Wikipedia or Quora, so we are talking about testing, okay, not unit testing. So unit testing is clearly one part of the TDD, but TDD is not only unit testing, okay? So which type of test do we have? We have end-to-end tests that work on the entire stack, integration test, so tests that work on some part of your application, and you have the unit test that work on a single module, function, class, object, whatever you want. So this is your single unit of work. But why is it so important to understand what type of test we have? Because if every type of test give us different feedback, and inside the TDD, the feedback is the more important things. Okay, so again, one beautiful handmade painting. So yeah, I am very good, and so very proud of this masterpiece. So unit integration end to end. Okay. Which feedback? Which type of feedback we can get from the different type of test? Okay, inside the unit test, the internal quality of our code is very high. So when you test a single class, you are detecting and you are applying some constraint inside how your code is written. So which dependencies are defined in this class, how this class they interact with the other class, and so on. So we get a lot of internal quality. Okay. The end-to-end, that is on the other part, on the other side, give us very little feedback on internal quality, because when you test your system, you say, okay, if I make this HTTP call, I want to get this response. Okay, but how this part is implemented, I don't know. Okay, when I try to implement an end-to-end, the internal quality of our system is clearly not our under control, and so we don't get feedback, but we get a lot of feedback of the correctness of our system and the external quality of our system. The integration is clearly in the middle, because when you want to put together some class, clearly you get some feedback on how is simple to connect this class, how our system is composable, and so on. And so clearly the integration gives us more or less the two parts. Okay, so the cycle of TDD again is add a test, run all tests, write the code, run test, refactor, repeat. Okay, so what do you think if you expand a little this circle and put, for example, a more external test that is what is called end-to-end or the acceptance test? For me, it is almost the same, that describe the feature that we want to implement. So give us a lot of feedback about external quality, and the unit test or integration test give us a lot of feedback about internal code. So the idea is that when you start to implement is to write an end-to-end and then write a lot of unit tests to obtain this this result. Okay, so the end-to-end test or acceptance test exercise the entire stack of our application. It remains red until the feature is completed, but very important, don't write too much end-to-end, because the end-to-end is slow and fragile, because clearly they are run the entire stack of your application, or at least at most part of your application. So clearly some part something get wrong very easily, and clearly it is quite slow. But where is the design? Okay, step back. So how application is done or should be. So I don't know if you ever seen something like this, but the idea is to write your application as is called hexagonal architecture or ported adapter, but the idea is to create an end-to-end that interact with your system from the external. So starting to interact with your system with the part that are available to the public. So for example, using an HTTP call, or interacting directly with the UI, or for example, if your system is fed by a queue, you can write some message on a queue. And if it is impossible, you can try to enter in your system, because your system is split in what is inside and what is outside. But yeah, we will see later. So if we start from the external, we will first of all write an end-to-end and then a lot of unit tests. So probably if you have tried to apply TDD, you have sometimes say this concept of outside in versus inside out. So outside in, we start to writing an end-to-end that explains the feature that we want to create, and add some unit tests to shape the behavior of the object that we want to create. Okay, we add some integration tests to verify that they work together, and so on. On the opposite side, you see inside out. Inside out is more or less the opposite of this process. So we start to writing some unit test. We add some integration, and we add an end-to-end at the end. So as you can see, at the end, you get more or less the same result. But why or when choose one process instead of the other? So my 2 cents. I prefer in general to use outside in when I have to create a new feature, because I like to start to think about what are the behavior that I want to add to my system. And so writing an end-to-end test give me a lot of feedback about this is the correct behavior that I want to implement. This behavior is correct. So for example, if you have to implement an HTTP call, writing the end-to-end at the beginning give us a lot of feedback about okay, this API is correct, this is the data that I have to give to the system, this is the result that I want. And so what's happened if, for example, I miss mandatory fields? And so it is very interesting, because it gives us a lot of feedback about the correctness of our behavior, the correctness on business level, not on implementation level. Clearly, if you want to start to apply this technique, you have to be not very, but a more experienced developer, because you have to interact with the entire system, you have to apply some not so easy technique, and so on. And so I prefer, for example, when I made some training about TDD, start on the opposite. So start to apply to inside in, inside out, to introduce the TDD concept in your team, because clearly it is more simple to make some tests on a single class instead of your entire system. I use inside out also when I add to feature and I know which objects have to change. So for example, again, applying the idea that test give us feedback. So if you know, okay, this object should be changing this way, okay, I made the test for this object, I change it, and okay, I get green for this part. But if I run the entire suite of my application, other tests probably will fail, and go on. Starting from this point, I will get the entire end-to-end. Okay, so it is clear until now. Some question, or are you still sleeping? So probably no question. Yep. So go on. Another important concept about TDD is probably mock. A lot of people say, okay, what is the mock, where I use it, and so on. So when to use mock? Okay, when we want to isolate one part from the other. Classic example, HTTP connection. Okay, we have to make some HTTP calls and manipulate the result in some way. How we can do it? Okay, so for example, take this code. Okay, and so you have a client, and you want, for example, get some information from Twitter about a person, and you can clearly in your test you cannot call Twitter, and so you apply this technique. As you can see, we define client ID. Yep. Give me 1 second. Pointer. Yep. Okay. So we define client ID, client secret. We define a mock, and we say, okay, I expect that this mock will be called with this function, with this parameter, and this return. This is the result that I want to get back. And so this is the test, the class. This is under test. And as you can see, I inject or pass the parameter as dependencies here. I call the test, and we expect the result. Okay. So one interesting point inside this test is, first of all, as you can see, I have 3 parts of the test. In TDD, we often apply what is called like the hey, or assert, act, arrange, act, and assert, or also when given that. So this is the first part where you set up your test and say, okay, this is the variable. This is the act part, or the part that make a change inside your system, and so get BO off. And then this is the expect part, so when you check the result. This test is not so good, but we will talk later, because this is a mock, but we are also testing the result, and so yeah, we will go on and we explain better this part. But this is a mock, and if we want to visualize where this part is here, as you can see, it is at the boundaries of our system. Okay, and so it is when we want to talk with external. And so, for example, we have to adapt how the Twitter client give us the information. So we are talking about making a call, set the authorization in the header, and so on. But my domain that is inside my core, it does interesting how the communication with Twitter is done. So the important part is that I want to get back the bio of this person. Okay, and so when you are at the boundary of the system, at the external, the mock is very useful, and give us also the ability to stop and to protect our system from the definition, implementation of our external system. Okay, so this is another example. Okay, suppose that you have a class that is called aggregation, and so again we have a class that is a point repository, and so we say, okay, we expect that we call this class point repository when we get the threshold. Okay. So again, if you look at this code, you will see that the bounds, so the relationship between aggregation and point repository is a repository, a relationship that is peer. So we will talk later, but in this case, the mock is a mock. So we will talk later what is the difference between mock and stub. So, but there is a question. Okay, so please go on with the question.
Yes, the
developer. Yeah.
People is asking. You wrote, forces the developer to think about the behavior of the code. So, which is the difference between E2E test and BDD?
Nothing. So for me, BDD and TDD is the same things. For me, BDD and TDD is the same things. I know the owner of so the father of BDD, and so we discussed a little. So for me, TDD also from the beginning was the same thing. So BDD start to rename the concept inside BDD because the name and how you call the things is very important, but the meaning for me is exactly the same. So when I talk about TDD and BDD, for me is exactly the same. So thank you for the question.
There are a few more questions. Do you want to take them now?
Sure. Okay. Go on.
Okay. Next one is testing frameworks. So regarding testing framework, do you have any particular recommendation?
Okay. So clearly the test is related to the language that we are using. And in this case, probably the most famous framework test is Google test. So yeah, Gtest and also Gmock. So I like very much Gmock, not only for the mock part, but also because Gmock give us a lot of very expressful assertion. And so you can write something like not only assert and so on, but say, okay, this value should be greater than the other. And when the test fail, you get more information about it. So probably, yeah, go on Google Test. I made a lot of different experiments, but for now it is probably a standard de facto Google Test.
Okay, so the next one is mock framework. Do you want to add anything to it?
Yeah.
Which is your experience about them? Which one would you suggest?
Okay. This is a very interesting question because could talk about mock for hours. But yeah, to make a long story short, if you can use a library like Gmock, but this is very important, don't drink too much Kool-Aid, or as sometimes say. So don't give your test, don't be too connected to the library. So for example, sometimes if I have to use, if I have a function that receive a lambda, and I want to test this lambda, I don't use a library, but I create a fake implementation of this lambda and put the assertion inside. For a small object, sometimes I wrote manually the mock, but clearly if I want to for example, like in this case, create a test or create a mock, I often use Gmock. There is a very interesting library that is called Fakeit, if I remember correctly, in C++, but I don't have ever used it, and so I cannot give you a lot of feedback about it. So I have used Google Mock, and it is a very interesting library. Also because force you to write as interface. That is probably the better part of TDD, because force you to create some good design.
There's a final one.
Yeah.
Final question is design patterns. Design patterns. Is there any specific design pattern you suggest to use for TDD?
I probably don't understand. What does it mean? Design pattern is quite a broadly topic, and so huge topic. So the idea of TDD is that testing give us some information about the code, and so clearly, if you see our old example, you have to create more composable code. And so, for example, inversion of control or dependency injection is something that is very useful. But a lot of design pattern is a choice that you have to do when you want to implement a piece of code. So TDD is not a silver bullet, and so it can help us to create a better software if we are able to write good software, good design. So it is only a tool that we have to use, and so which pattern choose when you have to implement something, it is probably very dependent on what we are implementing in that context.
Thank you. Questions, finish it for now.
Yeah, go on. Okay, so in this test we are expecting and we are using a real mock. So what is the difference between a mock and a stub? So as you can see in this code, the expect is missing. Why? Because the expect is inside the relationship between our object under testing, that is aggregation, and the relationship with point repository. So what we are saying is that when we reach the threshold, this method should be called. If this method is not called, this test failed, and this is a mock, because the mock is something that can break your test, and this is an assertion. The stub is when you want to fill a gap. So suppose that aggregation require another dependencies that is not interesting for the test. You use a stub in that part. We will see some example in the next test. Okay. So when to use mock again? In the time, for example. Suppose that we want to save the event when the threshold is reached. Again, we have now say that we want to call story event with the name and the time. Okay, and very interesting things. If you try to run this code, you get a fail. Okay, and why? Because there is a problem on time. Okay, because this time is not the same that you get outside of the test. And so sometimes say, oh, I have a tool that I want to fix it. No. This is not a tool problem. This is a design problem, because the time is a dependency. Okay, how to solve this problem? In this way, because your test require an object that take care of your time, because otherwise the now is not the same inside your test. And if you work, for example, with some code that is very time sensitive, you want that all the objects that are inside your unit of work have the same time. And so it is quite useful if you have an object that take care, okay, this all these operations are executed at this time that is exactly the same. And it is very useful and very easy to implement this part if you have an object that take care of the time. Like in this way, as you can see, in this way, the mock repository is a real mock and the clock is a stub, because the clock is used like something that is required by our object. But if we call, for example, now 1, 2, 3, or we don't call the now, this test is not broken. But if we don't call story event, this test is broken. Okay, I hope that is quite clear, the difference between mock and stub. But in this case, mock, the clock is a stub, and the point repository is a real mock. Sometimes the library call the same thing, so mock and stub, but this is by the book the real difference between the two type of objects. Again, this is the implementation. Clearly, you have the clock, and you get the now from the clock. And so, for example, oh, the now is in UTC, is the local time. No. It is the now. The now is now. How to manage periodic tasks, for example. Okay, divided tempera. So, for example, you create some task that take care of executing some object in a given time with a set timeout, and then you implement the part the code in a different object. In this way, you have split the logic in two parts. Often this implementation is made inside a single object, but if you start to decouple this part, it is quite easy to, for example, be sure that your scheduler is correct and the logic inside the code that is scheduled is correct. Okay, so for example, this is another example, and where to use objects. So where are the parts inside our system that are using the mock? Again, we are at the boundary of our system, and again, the mock give us the ability to protect the code from our infrastructure. So, for example, in the previous example, we have talking about repository. The repository hide all the complexity to interact with database. And for example, one of the objections they say, oh, but I want to know if my database is a Postgres or is another database. So clearly, if you have a database that is, for example, I don't know, DocumentDB or a graph database, your application is different from an application that requires to store some data in a relation database. And so the idea to create an object that abstract your database is not because you can easily swap between Postgres and MySQL or other database, but because you want to protect the domain, the core of your application, from all the details that is necessary to interact with the database. Okay, all these parts should be segregated in some different part of your code. Okay, when to use mock again? So the mock is a very important part for me. And so interaction between two objects. Okay, so suppose that we are talking about a card, like a classical. So the Black Friday is over, and so probably you have buy a lot of book about good design, and so suppose that you have to receive a discount if you are a golden user or something like this. And so, for example, you want to create and to shape the relationship between the card and the discount engine. And so, for example, in this way, this is the test that you should write. And so, okay, there is a cart. The cart is our system under test. And so when I add item to the cart, I want that the cart call the discount engine, and the code, the discount engine should return 01, because the user is something that I expect. Okay, and as you can see, I don't write this part. because I don't want to understand. The test is not if I apply correctly the discount that I receive from the discount engine, but the test is I interact correctly with the discount engine. So I pass the user correctly to the discount engine. Okay. This is the focus of this test, the purpose of this test. Okay. And so the tracking system, oops, sorry. So the tracking system in this case is a stub, and this is a real mock. Okay, so go on, and this is another test, and again the object now is the opposite, and so in this case the discount is a stub and the tracking system is a mock. Why? Because I want to test that when I remove an item from a card, the tracking system is called. Okay, so I have add, and as you can see now, the add is in the first part, so it is in the sorry, it is in setup of the test, and now this is the act. When I remove, I want that this test fail if you don't call the product removal. Okay, so where we are in the code. So as you can see, the mock can be used in all the part of our system, because now we are defining the interaction between the object, the protocol. So this is a very interesting part of the mock, because when you use the mock, you can create a protocol, so a specification between how the object interact between each other. And this is very important part if you are applying an object-oriented design, because this is object orientation design. Don't use mock on the object that you don't own. So for example, if you remember the first example, we have the external system. So I have an external library. I want a tool that give us the ability to, for example, mock not an interface or an external library. No. This is not a good idea. So put the external library under your control and make that your test, the core, is depends on an interface that you're under control. Okay, so don't try to use the mock for mock an object that is, for example, defined on a different library, or for example to mock an object that is a value object like the user in our test. So instantiate the user and use the user. Okay, the mocks is very interesting when you have some object and want to interact with each other. Okay, so mix everything together, because probably we have we are at the end of our time, if I remember correctly. So we have some question, right, Stefano? Yeah, we have still 7 minutes. Okay, so
there are questions, and the first is: periodic tasks may be very long and the unit test should be fast. Isn't it better to inject the timer clock in order to test it, so you can have a fake clock where you can force the time?
Yep, but when you have a periodic task, what you want to do is to remove the logic of that is called, and so what you want to do is simply be sure that your test is executed at periodic task. So in this case, what I have shown before is a more integration test, because they really wait the time that I've passed. So suppose that you have a periodic task that is based one time a day. Clearly in my test I don't want to wait until a day, but for example I say that my periodic task is still wait 1 minute. Okay, or if you want, you can apply what I described, and so again split these two parts and say and keep an object that take care all of the time, and the scheduler asks to that object, is 1 day passed, and say yes or no, and decide if want to trigger the behavior. But yeah, you can do it.
Okay, next one is, don't you think that tests with mocks are quite intrusive?
Very interesting question. In a unit test, you are interested in the behavior? Yeah. Okay. Yes and no. So if you don't use mock correctly, they could be easily become very intrusive. So because as you can see in our test, I want to describe using the mock only the interaction between two objects. So what I'm trying to say is that when this expectation is met, so when, for example, I reach the threshold, I want to inform the another object that the threshold is reached. How this part is implemented inside the object should be not exposed in the test. So this is a very important point, and if you think and if you start to understand that your test is very connected with your implementation, you are on the wrong side. And so yes, pay attention that your test is not quite intrusive, because the mock should be only describe the protocol that you have on another object. So for example, if you in your test start to say, okay, this is the order and I want to call this 2 times, this other object 2 times, probably this is a sign that you are not a good design. Thank you for the question, very interesting.
Next one. So, is a stub a component that is not tested itself, but it still is necessary because of the interface or how you build other components under test?
Yes, exactly. So, as you can see in the previous test, this is clearly the context of the test that define if this dependency is a mock or is a test. So we have two examples before. One test say that the dependency A is a mock and the dependency B is a stub, and another test that made the opposite. And yes, so if you have an object that requires 2 dependencies, for example, in one test, all the 2 dependencies are 2 stubs because you are interested on the result of the function, for example. In another test, one of the 2 is a mock, the other of the stub, and another test is the opposite, for example. Yeah.
Okay. Just the last one, at least for now. Do you think that mock objects should be used in integration tests or just in unit tests?
Clearly, in the unit test, if you want to shape the protocol between 2 objects, otherwise use the real object. In integration, it is quite useful. For example, if you want to isolate your integration from the external part. So suppose that you have an object that should interact with the database and, I don't know, an external queue. You could have an integration that interact with the real database, but with a fake mock queue, and another test make the opposite, and another test that interact with the real queue implementation. When you are using integration, when you are writing integration test, you are interested in the real part, and so probably it is not so common to use some mock, but it is a tool that in your toolbox, and so you can use it or not. It clearly depends on the context.
Thank you, Gianluca.
Okay, we have 2 minutes again. Okay, so we could try to mix everything together in the last 2 minutes. So what is the first test to do? We could start from the outside with an end-to-end test to enter inside our system, or we could start inside of our application and adding some unit tests on some object. Create at least one test, one end-to-end for every user story. Don't create too much end-to-end because they are slow and fragile. So this is an example, okay? This is an end-to-end, and so for example, as a logged user, I want to see my current card. Create card for current user, total, get my window, get card window for current user, get total, and I expect that the total is the total that I have. Okay, so as you can see, I create a lot of helpful or helper object function inside our test. But this is really the first test that I wrote. And so in the beginning, I wrote this test and I say, okay, this is the test that I would write. And so this is also called wishful thinking. So what are the tests that I would write? And so I write this test and I try to make it works. And so, for example, I try to create the function that is create for and go on. And after that, when I create this test, I'm sure that this test is correct. I start with the implementation, so end-to-end, unit test, integration, until this test became green. But this test remained red until at least the first happy path of the feature is implemented. Another example is, for example, as a logged user, I want to pay my current card. And so again, create card for, create payment info for, and get the payment window, and I want that there is, the payment result is successful. Okay. So as you can see, this is an example. So we are running low with the time. So go on. The end-to-end remain red until all the cycle is completed, and after that we have written end-to-end, we go inside the core and start to create unit testing. So which unit testing we want to write? Something like this. Calculate card total when add item. Okay. Again, these two objects, tracking and discounting, in this case are stub, because I am interested with the total of the card. After that we have written the unit test for the core, we could move to the boundaries. And so, for example, write some integration for the adapter. For example, interact with the database. That, in my humble opinion, this is integration test. This is an example. Okay, build card with some item, and so I want to save this card, and I get this card, and I say that the card that I've written, the card that I get from the database are the same. Write the test before. This is very important. You have to write the test before we are doing design. We are shaping the production code, and the code became more composable. It is more clear where are side effects. I'm listening some noise, probably. Okay. So just a recap. TDD is not a silver bullet. TDD don't give us a good design if we are not able to do it. Listen your test. This is very important part. And this is some reference, and that's all, folks.
Just in time, because we are waiting for everyone in the track A for the closing message. You can follow up with Gianluca on the networking area. Thank you very much, Gianluca.
And thank you and sorry
for our participant. Bye.
Thank you. Bye-bye.